Hi everyone, in this lesson we're tackling polynomial inequalities, where curves, sign charts, and critical points all come into play. You're going to learn how to find the intervals where a polynomial is positive or negative, and how to sketch a quick number line to show it. So let's dive right in. So we wrote you the steps here on the left-hand side for every single question. So we're going to go through every problem together using these appropriate steps. So the first thing is you want to make sure that one side of your inequality is 0. So in this question it is, so we're all set to go. The next thing you're going to do is factor to find all the zeros. And these we call our critical points or critical numbers. These critical numbers are where the behavior of an inequality can change. So here we're going to factor, and this is almost like a quadratic except it's x to the fourth. But we can do x squared times x squared to get us x to the fourth. And what two numbers multiply to 9 but get us that negative 10? That's going to be negative 1 and negative 9. And this is greater than 0. So now we can keep factoring because we have difference of squares. So this is x plus 1, x minus 1, and then x plus 3 and x minus 3. Again, all greater than 0. So now you're going to actually solve and find these zeros. So you're going to get x is either positive or negative 1, and then positive or negative 3. We're going to put these critical numbers on a number line so you can determine the test intervals. So we're going to make a number line here with our numbers. So we have negative 3, we have negative 1, we have 1, and we have 3. Now the fact that you have a greater than symbol means that you're going to have open circles on your number line. So now what we're going to do is we are going to choose test points in each of these intervals, and we're going to substitute them to see which of the intervals yield either a positive y value or which yield a negative y value. So let's just pick some numbers. So at negative 3, we're going to have, to the left of it, we can pick like negative 5, okay? So we're going to pick negative 5. And we're going to plug negative 5 in back into your inequality, and you're going to see whether you're going to get a positive answer or a negative answer. So if you do negative 5 squared, that's 25. You're going to get 24, so that's a positive number. And then you get 25 minus 9. Again, it's a positive number. So a positive number times a positive number is going to be positive. So where you would have anything to the left of negative 3, you're going to get a positive answer. Again, we're not focused on what the actual number is. We're focused on whether it's positive or negative. So now let's go ahead and choose a number between negative 3 and negative 1. So you could do like negative 2. And again, plug negative 2 in. And we've got 4 minus 1, which is going to get us positive 3. And then negative 2 squared is 4. And then 4 minus 9, again, that's a negative. So a positive times a negative is a negative. So the numbers that'll be in between negative 3 and negative 1 are going to be a negative value. All right, so in between negative 1 and 1, we could pick 0. So you got 0 squared minus 1 is a negative. 0 squared minus 9 is a negative. So a negative times a negative will yield you a positive answer. Between 1 and 3, you can pick 2. So 2 squared is 4. And then you have minus 1 is positive answer. And then you have 2 squared minus 9, which is going to get you a negative, which will get you a negative answer. So now from 3, we'll pick 5. So 5 squared minus 1 is a positive. 5 squared minus 9 is a positive. So that'll get me a positive answer. So now what you're going to do is you're going to use this number line. You're going to visualize it as the x-axis. And you're going to use what you know about end behavior and multiplicity to sort of visualize what's going to happen with the graph. So you're going to make sort of a little curve. So when we do this, you're going to think about that you have an even degree, and you have a positive lead coefficient. You're going to think about the fact that both of your ends should be pointing up. All right, so let's do that. So we know that both of the ends, right, where our graph is going to be changing, the behavior of the inequality could be changing. They're both going to be pointing up. So now we know that the y value should be pointing up. Between -3 and -1, it should be negative. So I'm going to go down below my imaginary x-axis. I'm going to go up towards the positive because I have a positive behavior that's happening there. Between my next interval, I have negative. So I should go below my imaginary x-axis that I'm using for my number line. So now what you're going to think about is looking at this symbol. So this symbol is a greater than. So I'm going to pick those intervals where it's greater than 0. So I'm looking at the pluses. So I have the intervals here, here, and here. So those are all the intervals where it's greater than 0. So now go ahead and write those intervals in interval notation. So here we have going towards negative infinity all the way to a -3. Again, it's not included because you have an open circle there. And then we have an or a little union. You have the next little interval is -1 to +1, union. And then you have 3 to infinity. All right, so let's try the next question together. So again, first thing is first, you want to make sure that one of your inequality sides is 0. So here what we're going to have to do is we're going to have to subtract 4x and 28 and move it to the left side. So what you're going to get is you're going to get 2x cubed plus 7x squared. You're going to get a minus 8x, and you're going to get a minus 28, and that's going to be greater than or equal to 0. All right, so step number 2 is saying that you're going to need to factor. So you can factor this either by grouping, or if you know how to use your factor box, you can go ahead and do the factor box. So I'm going to show you how to factor by grouping using the box. So what we're going to do is we're making our box. We're going to pretty much group the first two terms together in the first row and the last two in the last row. And on the outside, you're going to put your GCF. So on the left-hand side, you're going to do your GCF of your whole row. So the GCF of the first row is going to be x squared. GCF of the bottom row is going to be -4. And then fill in the top. So what can you multiply to get your first column there? So that's going to be 2x. And then you're going to have 7. Okay, so now we factored by grouping these together. So you have x squared minus 4 and then 2x plus 7. And again, you're still having it greater than 0. You can factor, you have a difference of squares. So you're going to factor a little bit more here. So x plus 2, x minus 2, and then 2x plus 7 greater than 0. All right, and then the next thing that you should see is, okay, I can solve, so you're going to get x's plus or minus 2 and -7/2. All right, we're going to make our number line. So you're going to put in -7/2. You're going to have -2, and you're going to have 2. Your symbol is in greater than, so we're going to have open circles here at our critical numbers. And let's test your interval to see what happens. So again, you're just focusing on whether you get positive or negative values, not what the actual value is. Okay, so let's say you can choose -5. So either row, whichever one is easier for you to do, you can just go ahead and plug that in to check to see what your values are. For the sake of this question, let's just do it to this row right here. All right, so you got -5 plus 2, which is a negative. And then you've got -5 minus 2 is another negative. And then you're also going to get a negative. So a negative times a negative times a negative is a negative. All right, so in between here, let's try -3. So again, just focus on whether it's positive or negative. So -3 plus 2 is a negative. You're going to get another negative. And then you're going to get 3 and -2. And then this one you're going to actually get positive. So negative times a positive is a positive. Okay. Let's choose 0. So you've got a positive, you got a negative, and you have a positive, which is going to get you a negative value. And we'll choose 5. So you've got positive, and you have positive, which will get you a positive answer. So now let's think about what's happening regarding your end behavior. You have an odd degree and you have a positive lead coefficient. So if you have an odd degree and a positive lead coefficient, that means the end on the left is going to be pointing down and the end on the right is going to be pointing up. All right, which makes sense. You have a negative, and then in this interval you have positive, so you got to imagine it above your imaginary x-axis number line is what we've got. And then negative should be below. All right. So your graphs will look something like that. Now you got to look at your inequality symbol, which is a greater than, right? Greater than 0. So we're looking for positive. So positive here in this interval, positive here. So this first interval is -7/2, comma -2. And then you have a U or union. You've got 2, and then pointing towards positive infinity. Okay, here we go. Last question. Again, let's make sure that your one side of your inequality is 0. So we're going to subtract 3x on both sides. You will get -2x cubed plus 12x squared minus 18x is less than 0. All right, now again, when you're trying to factor this, you're going to consider, okay, well, I can't do factor by grouping. I only have 3 terms. I'm not able to do a like quadratic factoring using my factor box. At this point right now, you can see that you do have a GCF. So the GCF is 2x. So let's factor out the GCF of 2x. And you're going to get x squared. You're going to get -6x. And then a plus 9. And still less than 0. So now you can see, all right, the inside that you have in parentheses, you could have a quadratic trinomial, which you can, again, factor using your factor box. This is going to be x minus 3. Again, still less than 0. Okay. Now when we solve this, right, we take everything. Let's solve this first one. Get x is equal to 0. Now, you do have 2 of the same factors. So that just means when your answer is 3, you actually have a multiplicity of 2. And if it's a multiplicity of 2, you know that your graph is going to bounce. So it will go touch that answer of 3 and then bounce still on the same side. So that's something to consider as we do our number line. So let's do our number line here. Here is 0. Here is 3. Again, open circles here at 0 and 3 because it is just a less than, not an equal to. We're going to test our intervals there using some test points. So we've got 0, so let's just pick -2. And again, for the sake, this might be easier for you to do, to choose it right here. -2 times -2, that's a positive answer. -2 minus 3 is a negative. And -2 minus 3 is a negative. So we're going to multiply, and you're going to see that you get a positive answer. All right, let's go in between. We could just choose one. You're going to have a negative, you're going to have a negative, and you're going to have a negative. So negative times negative times negative is a negative. All right, and then let's choose 5. Again, plugging that in. You're going to get a negative, you're going to get a positive, and you're going to get a positive, which will get you a negative. So now when you go back and you check what your end behavior is, you're going to see you have an odd degree with a negative lead coefficient. So it's reverse of the other problem that we had. So that means on the left side of your graph, you're going to be pointing up. And on the right side of the graph, that means you're going to be pointing down. Okay, so we know here that we've got to be under my x-axis, but because at 3, I know that it bounces, I'm going to touch the x-axis and then bounce back down. It is a less than, so I'm looking for negative, so I've got 2 intervals here that have got negatives. That first one's being 0, 3 with the u, and then 3, infinity. Okay, so overall, you need to remember that polynomial inequalities are all about knowing where your graph changes signs. Hit like if this made sense and stick around, because next time we're going to tackle polynomial long division. And remember, we're unlocking the power of math, one problem at a time. See you next time.